Hi there, my name is Heinrich and today I'm excited to be doing this workshop session with you about forces and Newton's laws. Without any delay, let's jump right in. Now, if you're going to be dealing with forces, the first thing you need to know about is vectors and scalars and what the difference are between these things. Now, scalars are those things that have magnitude or size or scale only, right? So we can describe it with a number, but it doesn't necessarily have a direction, whereas vectors have those things that have both magnitude and direction. Now, vectors we can represent with arrows. So an arrow like that is going to show us the direction that the vector is going in, and then the length of the arrow is going to represent the magnitude of the vector. So having a longer arrow means a larger vector, and a smaller arrow means a smaller vector. Okay, so multiplying a vector by a scalar is going to give you a vector. That might be something useful to keep in the back of your mind. So let's see here a few examples of vectors and a few examples of scalar. So vectors, displacement, velocity, acceleration, force, which we're going to deal a lot with today, that's a vector, momentum, impulse, electric field. And what's fantastic about these vectors is the math is all the same for them. So if it's got a magnitude and it's got a direction, you can use an arrow in order to represent it, and if you've got that arrow, you can use that in order to do the same sorts of calculations, addition, etc., etc. Whereas scalars are those things that only have magnitude, so distance, speed, mass, work, and energy, and of course time is only going to go in one direction, isn't it? Right, so let's talk about vector addition. Now, vectors are most easily added together when they are acting in the same line of action. So same line of action means that either they're going to be in the same straight line, but they don't necessarily have to point in the same direction. Now, the golden rule for adding vectors together is that vectors should be added tip to tail. Right. Now, the resultant vector starts at the start, so at the tail of the first vector, and then ends at the end. It's going to end at the tip of the second vector. All right. So let's say that we've got these two vectors over here that are acting on the point, that pinkish dot. Right. So if we want to add these vectors together, we've got to arrange them tip to tail. And there you can see that the tip of the one vector is at the tail of the other vector. And the resultant vector is that vector that we get when we start where we started and end where we ended. So the arrow that we draw from the start to the end, basically, that's the resultant. Right. So then, if we were to put numbers on this, we could say the one vector was 10 newtons to the left, so now that we've put the newtons, we know it's a force, and the other one, 4 newtons to the right. But now in order to add numbers together, we need to do that thing where we nominate a positive and a negative direction. So in my instance here, I'm going to take left as being positive and right as being negative, and that then means that I can go 10 minus the 4 in order to get the 6, and that then means that that resultant vector is going to be 6 newtons to the left in the positive direction. Okay, right, so then we can add vectors together that are not necessarily in the same line of action. So let's see this over here. We've got those two vectors that again have been represented as acting on a point, and now I'm going to add them in exactly the same way as previously, tip to tail, okay? And the vector that starts at the start and ends at the end, that is the resultant vector. Now, you might ask, how do I know which one goes first? And the answer is, it doesn't matter. If I put the other one first and then added the second one to a tip to tail, I would get exactly the same vector. And this is often called the parallelogram rule for vector addition. Right, so here is a good time to note a particular difference in how we lay things out. Now, on the left-hand side there, we've got forces acting on an object. Now, when vectors are acting on an object, we're going to put the starting points, right, the tails on the object, right? And then the arrows point off wherever they're pointing off. But if we are going to add the vectors together, we cannot put the tails on the same point because we have to arrange them tip to tail. So if we are going to be drawing a diagram, we have to be certain, are we drawing this as vectors that are acting on an object, on a point, or are we trying to add these together, in which case it's got to be tip to tail.